In this video, we're going to introduce the inverse trigonometric functions. And we're going to do that by leveraging what we already know about the forward or regular trigonometric functions. For example, we already know how to calculate the sine of an angle. One way to do this is simply to go to our calculator and evaluate what sine of pi over 3 is. When we do that, ensuring that we're in radian mode, as we by default are in a calculus class, we get this number 0.866 and a continuing decimal. Another way to approach this, of course, is to use one of our classic triangles, the pi over 3 and pi over 6 triangle, or a 30-60 triangle, and that has the ratios 1, 2, or the side lengths of 1, 2, and root 3. And if we do sine, it is opposite over hypotenuse, so we could get a more exact answer for this sine value, which is root 3 over 2. Now, unsurprisingly, there may be times where instead of having the angle and getting the ratio back, we might want to start with the ratio and find the angle. For example, if we were to take a triangle with side lengths 3, 4, and 5, hypotenuse being the longest one of those three, and a right angle triangle, we might ask, what are the two angles that make up this triangle? And most of us, I think, at this point would go to our calculator again, and we would use the inverse or the shift sign button. For example, if we wanted to find this angle, the sine of that angle would be 4/5, and using our calculator, we would get a value of around 0.927 radians. We could also do the same thing for this angle as well, and that we could either do with a sine inverse of 3/5, or we could use inverse cosine. For variety, let's use the cosine. That's cosine of, say, 5 for that angle would be adjacent over hypotenuse, so the same ratio but a different function. And with our calculator, we would get around 0.634 or 35 radians. And we could convert those to degrees if we liked. There's a bigger question at stake here, though, and that's what we're going to look at next. When we use our calculator to do these operations, to compute those angles, in principle that seems okay. If we talk about how we actually computed that, we took advantage of the button in the calculator, that might be the shift sign or sine to the power -1, noting that this power here really expresses the inverse and not the reciprocal. And reciprocal just means the 1 over something else. This is not 1 over sine. It's the inverse of sine. It's an awful notation. We'll introduce an alternative soon. The question is, what's going on with this button, and why in particular, as mathematicians, should we be suspicious of this magic inverse button? Well, one of the things that we're doing here, if we talk about the inverse of a function, is we are trying to go from x values to y values with a sine function. That's pretty normal. But the inverse is going from y values, we say 4/5, for example, and this is the graph of sine of x. We're looking for the angle that gives rise to that. Well, there's not just one angle that does that. There's another angle here, and there's another angle here. And in general, there's actually more angles back here as well that we could have used. And yet the calculator is only giving us one of these. The calculator answer here is one of these infinite number of choices. The fundamental issue here is that sine of x is not invertible. For those who remember your tests for functions, there's multiple crossings of a horizontal line. So this fails the horizontal line test. And that means if we pick a y value, we might get multiple x values back. So there's no single inverse. But the calculator's doing something, so how do we get around this issue? How does the calculator adapt to this fundamental mathematical problem to give us at least some answer? Let's take a look.